Hello, everybody, and welcome to the last Engineering Excellence Talk. I hope you are enjoying the whole conference. Before we begin, please let me share some quick information. This session is being recorded and it will last 55 minutes. Today's agenda features a speech from our guest and a Q&A session at the end. If you will have any questions, please put them in the chat. It is with great pleasure that I introduce our speaker, Von Vernon, who is going to give us a speech with intriguing title, 3 Architectures, 2 Surprises, 1 Mission. Von Vernon is an executive as architect, entrepreneur, and strategist, with more than 35 years of experience in a broad range of business domains. He is also an author of 4 books. Ladies and gentlemen, please join me in welcoming Von Vernon. Hi, Von, and welcome to EngX Community Day.
Thank you so much, Marta. Well, I have hopefully an intriguing title to think about: 3 Architectures, 2 Surprises, 1 Mission. And let's just jump right into this topic and uncover the mysteries. Marta mentioned my authorship of 4 books. These are the first 3, 2 about domain-driven design. Maybe you've heard of Implementing Domain-Driven Design, my first book, and Domain-Driven Design Distilled, which is a smaller book, shorter book, and then Reactive Messaging Patterns with the Actor Model. But this is the newer one, Strategic Monoliths and Microservices, Driving Innovation Using Purposeful Architecture. And a lot of the material from in this talk is taken from Strategic Monoliths and Microservices. So let's jump right in. If you have ever been to, let's say, Scotland or Northern England, you probably understand what a bog is. A bog is a little bit like a swamp, but actually a swamp I think of as being more in tropical areas. A bog is more muddy, and the interesting thing about a bog is that, as sort of bad as it may look like this, it's still actually quite useful. It has value. So when we think about legacy, as in a legacy system, and we think about experiencing, right, we're not real happy with having to work in an area like this with a bog, but at the same time, what we have to understand is that a bog has value. It's valuable, although to humans, it's inhospitable. You wouldn't want to drink from this water. You wouldn't want to swim in this water. You probably wouldn't even want to take a shortcut and cross through this water and mud to reach the mountains that are in the background. And yet, this is very important to the ecosystem wherever these bogs are found, because plant life, animal life, various kinds of living things are hosted in this bog area, and the bog also provides minerals and moisture to the surrounding area. So it's valuable, and this is very important to think about when we compare legacy systems that we think of as being the big ball of mud, and that is a good description for them, but they're also valuable. So while the big ball of mud legacy system is inhospitable to humans, as in software developers, we go in there and we feel uncomfortable. Anything that we change might break something else. And it's kind of a fearful environment, in that what happens if I change this one property in, one part of the software, will that have an impact on an area of the software that I am completely unaware of? It's hard to tell. So many times when we make a change to legacy software, it can take months and months before that change can be released because of all the testing that has to be done to ensure that we haven't broken anything. And many times, even though we go through a lot of human tests, with generally missing automated tests, it's still quite a an inhospitable environment for everyone. So we can still get bugs even when we think that this legacy system is well tested. But this is what I'm talking about, that it has value. So if legacy systems didn't have value, they wouldn't still be running. The point of legacy systems are that they are legacy because they work. As perilous as it is to try to make a change to the legacy system, and as much discomfort and lack of hospitality that we receive as people going into that system, it's still very valuable to the organization, to the company, the business that owns it. So we have to be aware of that. And at the same time, though, this legacy bog, should be changeable, because we find that as time moves forward, we have to innovate in the areas of the business. So, for example, here we have a big ball of mud that is used for in a banking domain. So you can see that we have deposits, we have payments, we have loans, we have electronic branches, and cards. And actually, maybe some of the payment systems need to be expanded, need to be improved a lot. And the e-branches, the electronic branches, we've been maybe working a lot with even the possibility of branch work that gets done and batched and sent over to the bank in batches, or even if it is somewhat real time, still the activity that the data and the changes to the data that are roughly immediately sent to the bank are still batched for later processing, because batch processing is how banks worked for a long time. But now we see digital banks are innovating all around. What is a legacy, or a bank with a legacy system, a very large system, going to do? How will they accept new forms of payment that they have never accepted before? All of this shows the dilemma that being an innovator in a big ball of mud has. We actually, as if we were walking across one of these bogs like this, right? What happens? Well, we can easily get stuck in the mud, and we're stuck in the bog. So that's the innovator's dilemma. Now, this is what we would like to achieve. We would like to have transformation, digital transformation, which I think is a very overused term, buzzword, or buzz phrase, digital transformation. But because it actually means different things to different people, it means different things to different companies. But whatever our transformation is, there's a very important requirement, and that is, don't break the money. So while we're trying to take this messy, piles of money in the legacy and arrange them very neatly. Maybe these represent microservices or even function as a service. Oh, wouldn't it be great to just have so many small microservices that we can just change them or unplug them, or we have a lot of different options, don't we? Well, actually, I'd have to warn you that once you have so many microservices running, it can be very difficult to know what depends on what. And so you can actually sort of unplug parts of a microservices deployment with a lot of microservices, and you can break the system in the same way that you can if you're changing the legacy bog with a lot of mud. You make a change to one property and you don't know what kind of ripple effect that's having across the legacy bog. Well, the same kind of condition exists here in this nice, neat, piles of cash that's counted, and we think that we have everything working. And actually, one of the things we think we can do, and that's readily make changes and redeployments, can actually be dangerous too. So how do we actually succeed in doing this? What I want to emphasize today is systems thinking and design thinking, okay? So, or systems thinking and systems design, they kind of go hand in glove. Now, this is what I was talking about in the title: 3 architectures, 2 surprises, but 1 mission. Notice that which is the architecture that we usually talk about? Isn't it the technical architecture that we generally like to talk about as software developers? Yeah, let's just jump into the technical architecture. We will get this new, the old legacy system replaced with new microservices, or even function as a service, AWS Lambda, whatever happens to be. Yeah, this is exciting. Let's jump in there and do it. Well, notice that I've actually hopefully surprised you a bit, and I've put technical architecture as the lowest priority in this stack of architectures. And here are the 2 surprises: business architecture and social architecture. And these are so important because if we don't get the business architecture right, and if we don't get the social architecture right, then we are just going to languish in the technical architecture, possibly completely fail, or it's just going to turn into a distributed big ball of mud, right? It's gonna be like having thousands of bogs all over the place. And that's very easily what can happen if we're not careful. So let's step through this and notice the colors that I've assigned to the business and social architecture. So business is green because I see that as green light, right? Like if you have the traffic light or the traffic semaphore and you see a green light, it means, go forward, go for it, right? And that's what we should really be focused on, is the business architecture. Now, closely related to the business architecture is the social architecture. And I've chosen the color blue here because social architecture should be a calming kind of environment. It should represent people working together to accomplish a business architecture in a technical way, but how do we actually make it calming? How do we make it a peaceful environment where we can still achieve very important work and innovate strategically, and yet not get people their feelings hurt and so forth. And I'll explain more in a moment why these two are so important before getting into the technical architecture. So let's jump into business architecture first. So remember, this is where we want the green light, let's move forward right away with the business architecture. Now, business architecture is a multidisciplinary kind of concern. And we want to focus on the business architecture, but it has sort of many parts. One of the things that we need in a business architecture is vision and strategy. So the vision will generally come from upper executive management, maybe not always the C-level executives, maybe not always from the boardroom, but they may call on vice president, senior vice president, someone like this to drive a vision and a strategy to improve whatever the overall business domain is, such as go from legacy banking software to true digital banking. And there are going to be multiple strategies in this, even though the vision might be quite large. There are going to be, at least a few, if not several, strategic maneuvers that have to be made. So that's a very big part of this. Communication is extremely important, because how can we actually be successful in business architecture without due attention to our quality of communication? And of course, we have to think about our business capabilities. Where do we start? We've got this big, legacy ball of mud, a bog, and how is it that we even know where to start putting, let's say, boundaries? Where should the boundaries of our microservices be? Where should the first focus be on certain parts of the vision and strategies that we want to move forward with? Well, we're going to examine the business capabilities and determine which of the capabilities are most important in realizing the vision and the strategies. So we're going to have to consider those. And we also need to treat everything that we work on, the whole system, as products. The data should be treated as product or products. There are likely many data products. And the software should be treated like products. Product thinking, along with system thinking, is a completely different way of looking at software and data than just releasing applications, right? In an enterprise, even when you think that you have a captive user audience, it's only going to be internal users, and you think that you can just get away with sort of releasing software that isn't quite as reliable as it should be. It doesn't have the highest quality. Well, you know what? That is not a product. That's just an app. Products have quality baked in, because when you have a product mentality, you have to think in terms of, who's my competition? Is it possible that we could be cornered out of the market and another product be brought in? Well, don't doubt that if you fail at software by just releasing apps that break down, that are constantly being changed, and users are failing, and you're getting a very bad reputation, it's possible that the business could just decide, either let's outsource this, or let's go purchase something off the shelf and we'll customize it, whatever it happens to be. So when you see even value streams here, they better be streams of value, product level value, not just streams of, let's say, stories or use cases or features or functionality. The value also has to be baked in as product thinking, systems thinking. And underlying all of this, you might think, well, executive buy-in and appropriate funding, that has to be the very first thing. Well, I've actually moved this to the bottom because it's foundational. To achieve any of the things above, you need executive buy-in. They have to have, the executive management must be willing to invest in strategic innovation. And by investing, they will have appropriate funding available to transform the business into digital banking, for example, rather than legacy banking with the big ball of mud. So this is quite important. Business architecture also includes the people involved, as in their communication structure. And I said that communication is very important, but communication and communicating individual mental models is hard unless we have the right attitude toward it. So just for example, look at the structure here. Notice that I highlight that there may be as little as 2 levels between the executive management and the actual software developers, or there could be 20 or even more levels. We don't, it's not like we can just set a limit and say, oh, we don't, we can have no more than 20 levels. Actually, there can be many, many levels, but when you have this arrangement, look at what happens. Communication is slow. It's unrefined. It turns into interpretations or translations at every level. It's like if you've ever played the telephone game, where you whisper to someone a story and they tell the next person, and by the time you're even 2 or 3 people receiving this story, the story has changed, right? And by the time you get to the 10th person, it's comical, even before that. So we have to think about Conway's law, and Conway's law states that the communication structure of an organization will directly impact the quality and the structure of the software, the design of the software that gets released. So if we improve our business architecture with appropriately assembled teams where lateral communication between the business visionaries, the business experts, and the developers are happening, then this can be a successful business architecture. When you think about digital banking itself may be a very high-level goal. But again, we have to think about the boundaries between, and the boundaries are actually reflected in the business capabilities. So you can look at deposits within a bank, or what may be known as accounts for account holders, payments, cards, customers, those things that we saw previously in the big ball of mud. Those are the business capabilities. And if we choose boundaries that are based on those business capabilities, we have these sort of natural divisions between the software per capability. And this is a natural kind of division because the language of each of those areas will tend to separate. Even though we may use some language terms across all of these business capabilities, for example, who's a customer or what is a client, and payments, maybe you make payments both for loans and for cards and so forth. But when you think about overall how we want to split this up, we want to think about, first of all, what are the large grain business capabilities, and then we can start sort of decomposing those higher level business capabilities into more fine-grained business capabilities such as fraud detection. And then we can make design decisions or more tactical design decisions, such as we're going to use machine learning for fraud detection, which is down here at the bottom. But up here, these are the strategic divisions based on the goals of the software. And then, look, we actually are seeing the business architecture reflected in source code. Now, we're not quite here yet, but I just wanted to show you that don't give up on this talk, because we actually will get to the technical aspects of this. But remember that business architecture and social architecture are extremely important. Modularity comes from strategic design. And notice that the communication, the language, the dialogue that we have within each of these capabilities, such as deposits, will actually also drive out internal modularity. So deposits is a module. You might think of this module as a DDD bounded context, a boundary, right? But even inside of deposits, there will be other boundaries, such as the account, or what is known also as the current account of account holders, the customers. And then you'll have a monetary boundary that deals with the sort of standard kinds of concerns that probably cross all boundaries, but this could be maybe what is known as a shared kernel within domain-driven design. But notice how these boundaries are set up. But if the problem with this is, if you're changing technical architecture without changing the business architecture, you're just going to run into problems, because what you're going to have is the old business architecture just in a new programming language. So we decide, let's leave COBOL behind and let's use Java or C# or something like that. Oh, that's going to make us feel much better, but you're still going to end up with the same kind of tangle and mess and broken communication if you don't pay attention and drive out the boundaries from the business architecture. So the impacts of business architecture is that business architecture really must be, it should hold a priority over technical architecture. And as I just said, if you change the business architecture or the technical architecture, I should say, change the business architecture, or the new technical architecture will have low value. You will simply trip over the continuous legacy ball of mud that will be brought in with the technical architecture. Invest in top mature developers to work on the core, and we'll get into the core more in a little bit. But now let's touch on social architecture. And this is something extremely important to understand about software systems. Software systems are made up of hardware and software, that as in they are comprising those, but hardware and software do not make those systems. People make software systems. People make the entire system actually work. And what we have to understand is that people have personal lives and limitations. People don't want to work more than 40 hours per week, even though sometimes that may be absolutely necessary. And we should be willing to do that sometimes. You know, we don't just walk out on a firestorm and let everything just burn down. But if we are carrying our business architecture and our social architecture correctly, then we're probably making good technical decisions, and those kinds of firestorms may never happen, or may be quite limited and be overcome throughout time. As time passes, there will be more and more, less and less of those, and more capability, right, to just leave and go home at regular hours. So we have to recognize that people have limitations, and people's situations, if we aren't careful, their situations will remain in the software long term. Even if we think that we can go and recover the people situations that are coded into the software, as in, you know, they don't have psychological safety, they feel threatened, they think they can't make mistakes. And even if you think that you can remove those, think of the investment that you're going to have to make beyond the initial investment just to clean up the software because people didn't feel good about what they were doing. Social architecture is extremely important. So let's look at two examples of teams. This is an example of one team and one team. Notice that the team is actually really right here. This is the software development team that's being affected by the communication through many layers or levels of communication from visionary down. And maybe this is the product owner here on the far left. And the product owner, you know, they're let's say they're trying to do Scrum, and the product owner is talking to them using fractured communication that didn't really work to begin with. And so they start talking to the developers who are on the right there, and the developers who are next to the computer are receiving translations. And by the time all this translation happens, you can forget about the original message. And what happens a lot of times is by the time the executive team or the visionary, the ones who are driving the vision and the strategy, once they see the software that isn't what it was supposed to be, right? It's too late. We can't go back and make changes now, because if we do, we're going to miss the client deadlines or customer deadlines that we were trying to make. On the other hand, this is an example of a team that is built around the recognition of Conway's Law, showing that we recognize that the communication structure will have a direct reflection into the software systems that we design and implement. So we don't want the loudest and longest talkers, the people who make so much noise, to damage our team structure. We need to think about the social etiquettes that are involved in making people feel comfortable. We want to fall out from the authoritative kind of voice and be open with dialogue and view every person on the team as capable of adding good value. And they need to feel psychologically safe in order to make those contributions, because they may be afraid of being wrong if people act as authorities and sort of punish them whenever, you know, even by laughter or joking or something like that, when they make a comment that doesn't seem correct, and yet it may actually be a brilliant comment, a brilliant reflection into the value stream of the software. But the authoritative voice and mind is thinking there's no way that this person can actually have valuable input. And notice here that we have another social architecture challenge. On the left-hand side, we have 3 teams, but notice that these teams are divided up by their skill level, right? They're the functions that they can perform as a UI team and a backend team and a DBA or database team, right? But notice that we also have 3 teams on the right-hand side, but these are cross-functional teams. This is where at least one individual from each of these previously siloed areas is assigned to 3 different teams, and these teams now communicate. Notice that the UI people they can only talk to one level, and we have the same sort of separation between individuals, where if we have communication among teams with cross-functional, we can make a lot more progress. So strategic innovation is hard, and here's how to think about the way that we must succeed with it. Strategic innovation introduces complexity. We can reduce the complexity by experimentation. And some experiments are going to fail. And this means that we require introducing and maintaining a failure culture, which means that we don't get in trouble for failing. And the failure culture requires psychological safety. Every person involved who could possibly fail needs to recognize that their failure will not be the end of their job. That's because we fail fast. We learn fast. We're not talking about failures that require a month or months to discover that this isn't going to work. We want failures to happen on a daily or hourly basis, or within a few days. We should be able to learn enough to know whether this is going to work, and if we're following the correct innovation and actually making innovations. And then long-term failures are avoided, and so nobody should actually experience any problems from this. Social architecture, well, I'm kind of repeating this, but you can understand social architecture better throughout the levels of challenge that teams will face. And this is called the Cynefin framework. I won't go into this a lot, but look into the Cynefin framework. Yeah, it's not spelled the way that you think it is. It's, I think, a Welsh, or I think it's a Welsh term. So you'll have to do a little investigation on that yourself. I need to move on with the presentation. But social architecture then means that we are investing in people, and not just like the top performers. We have to invest in everyone. And those people, everyone, can become top performers if they feel that the business is investing in them, listening to them, and if they have a safe, calm environment in order to make systems. Because remember, if they don't, their unsettled, fearful attitudes will end up in the system architecture itself, the implementation. So, and each of us should learn to listen more than we talk. Think in terms of team dialogue, where everyone has an equal opportunity to speak their mind and come up with ideas and make suggestions, but also we have to even listen to others and say, in a reasonable way, we don't have to be right all the time, and we needn't feel threatened if we're not right even most of the time, because we are contributing, right? We're bouncing ideas off of one another. Now, look, we finally reached the technical architecture. And I have to say that for several years now, many years, I guess you could even say, that when clients approach me, they are all dealing with this kind of big ball of mud, or the legacy bog situation. This is nothing new. And so if you are working in an environment like this, don't feel that you're the only company, or you're the only team or group of teams that are working on these kinds of systems. It's got to be at least 99% or higher number, as in 99.99 or 999, you know, 5 nines maybe, so that are experiencing this. So we have to ask ourselves, is monolith bad? Are monoliths bad? Small is beautiful, right? So that must mean that monoliths are bad. Well, not if we have boundaries and we view the monolith as a deployment container, but we actually have those modular boundaries within that represent bounded contexts. And in fact, in time, we can even break up the monolith into microservices, and the autonomy will stay much the same if we have clear boundaries, separate databases, and weak coupling. All that you'll be introducing when you take one of these modules out of the monolithic container is you'll experience the introduction of the network, which can be challenging enough, but it doesn't mean that you have to break all of these modules out of the monolith. You should be able to justify through purposeful architecture that any one or more of these module boundaries needs to be broken out into a microservice. Otherwise, right? If small is beautiful, tiny is painful. This is where you now have all these microservices that you don't really understand them. And if you unplug one of them, as in you decommission one of them, undeploy it, just one of those steps can cause catastrophe across the entire system. Be mindful that tiny, tiny microservices, as in a single entity or potentially even smaller, is very likely just too small. And people who think that performance is going to increase by introducing microservices are following the wrong path. When you involve the network heavily, right, when there is a lot of network chattiness, it's going to slow the overall system down. Call chains become unreliable. Shared database across microservices and strong coupling introduces what I think of as the Jenga smell. It's, remove one of these pieces from the Jenga tower and the whole thing can come crashing down. Even if it doesn't crash down on the first one, maybe the overconfidence that we gain by, decommissioning one of them makes us think that we can decommission more, and all of a sudden we have the new Twitter, right? Where, what is it, two-factor authentication just stopped working because someone decided to start unplugging microservices, right? Very few of them are even needed. Well, that's a good way to find out whether they're needed or not, right? So 99% of the industry is the way it is because 99% of the decisions made are technically driven. This is where the technical architecture is driving the business rather than the business driving the architecture. Going from mainframe BOG, legacy BOG, to microservices, but retaining the same thinking, the same business thinking, lacks a recognition of strategic business outcomes, and thereby, wherever the new boundaries are, these boundaries are just technical. They're arbitrary and very likely wrong because they're not driven by business capabilities. They're driven by the observation of how the software was built decades ago and is now a tangled mess of legacy. And try to avoid adding more layers. Sometimes if you're going to maintain the legacy software, adding a layer is important to do. But if you start adding layer upon layer upon layer, you're just painting over the problem and you're going to end up feeling pain. So remember, business capability is the what. What does this digital bank need to do? Process is how. So we first have to understand the overall vision, strategy, think about the business capabilities, align boundaries with business capabilities, and then concern yourself with the business process, the how this is done technically. Again, modules are important. I showed this before. Now we have, okay, oh boy, this is what everybody, all the programmers just wanted to know. Okay, when do the aggregates happen, right? When do we have commands, aggregates, and events? Well, we introduce those in the technical architecture, which again, only happens well if we have the business and social architecture correct. So we can have our transactional boundaries as aggregates. We can use domain services as a tactical tool, as you see here. This is now an insurance policy environment, an insurance domain instead of a banking domain, but it's still financial services. And notice what a nice sort of, little method or function here we have. This is actually C#, but in a functional expression of the actual implementation or the business process. And notice that we just have a few lines of code that read very well. And sure, there's going to be some complexity, but we reduce the complexity as much as possible by not self-inflicting complexity into the software. So we have to think about the overall process with the technical architecture. Yes, we can introduce process managers or sagas. Oh, we love those. As developers, we just want to really latch onto those and get it done. But it's not that simple. So just beware that when you introduce these, you have to really think about the coupling involved and trying to maintain loose coupling so that the system will operate continuously without a lot of tangle. How is that done? Well, there's a lot to that. And remember that the technical architecture must be carefully defined. Otherwise, we're not going to end up with these nice, neat piles of money. We're still going to have the same tangle as we had before. Technology itself, such as databases, messaging systems, gateways and APIs and things like that, they have their limits to the technical problems that they can solve. And they do not generally solve business problems. The business problems have to be given focus through the business and social architecture. Otherwise, again, the technical architecture will just be fairly useless and error prone. So invest in purposeful architecture that solves problems, not adding more problems. And I think maybe my time is about up. So I just wanted to show you a strategic design tool that my company Kalele has developed. It's called Domo, and you can currently reach this event storming and DDD context mapping and use impact mapping like you see here for strategic decisions. And you can use all of those tools. It's currently free. You can register for free. And I welcome you to go to domorobo.to and register and sign up. We have many users already, and we're adding more tooling and making the platform more extensible all the time. So I want to thank you for attending, and thank you to EPAM and EngX for inviting me.
Thank you so much, Von, for your presentation. We found a lot of takeaways for all the listeners. I'm sure about that. Now we have some time left dedicated for the questions. I saw two people posting the information about the frameworks and the framework you mentioned before. So we have the links already. And also one person commented that I've been attempting to work this framework into some of transformation engagements. So we are even using it. And we have a question. Does Von have other examples of effective social architectures? We explore teal-based peer network and value creation networks where specialists can self-organize by domain, but any other examples from his experience?
First of all, can I understand what you mean by framework? What is the framework being referred to?
It was this Cinefin framework, if I'm
Oh, Cynefin, yes, okay. So
yes,
you've
yes.
used the Cynefin framework before. Okay, good. And then the question is, with regard to the Cynefin framework, what was the remainder of the question, please?
Yeah, so first was the comment about like that they use this transformation, and the question is different. Do you have any other examples of effective social architectures? We've explored tool-based peer networks and value creation networks where specialists can self-organize by domain, but any other examples from your experience?
Well, team topologies is another one to introduce, but I just want to make clear that the social architecture that I'm discussing here is very much about the people themselves, right? The people that are involved in building systems, they have a direct impact on the results of creating these systems. And if they don't feel comfortable, if they feel stressed, or if they're dealing with something in their personal life, maybe a sick, husband or wife, or maybe a sick child, or who knows what many things. Maybe they themselves are ill, or maybe they're having financial problems. Whatever it happens to be, we have to understand that people have problems and limitations, and they get exhausted and tired, and they may need a lot of support. Also, a part of this is trusting your engagement with business people. So software developers often miss really good opportunities to engage with the business because they're always trying to translate from the business to the technical architecture. And this kind of translation creates a fracture between the two. And many times the developers are trying to correct the language of the business or teach them something about technology. And really, many times, especially in these kinds of businesses, like, for example, banking, insurance, medical, these kinds of healthcare, these kinds of environments, those business experts are really not going to have, or even have, a desire at all to be involved in the technical end of the architecture. So we have to respect that and trust their expertise. So yeah, team topologies can help, but team topologies in a lot of ways only addresses the technical aspects. But for example, in the stream aligned teams, what's called stream aligned teams of team topologies, business experts should be part of those stream aligned teams. Now, if you also have platform teams, complex subsystem or subdomain teams, and what is it? I just slipped my mind. Basically the support, enabling teams, right? Basically supporting the value stream teams. They're kind of broad in terms of their knowledge. And so any of those teams that need business savvy, right? They need to really understand the business and how it works, should engage respectfully and trustingly with business experts. If you want to look at books, well, we do get into that in Strategic Monoliths and Microservices. We talk about the people and the psychological safety in here, as I said. This book in particular, Domain Storytelling, is a very important tool to use, and it has some aspects that are similar to event storming, let's say, but different. They're both sort of graphical, pictographical, visual kinds of tooling, but domain storytelling is very close to stories, right? How do you describe stories pictographically? I would suggest picking up this book, and it will help you to engage with business experts. And it kind of puts you all on level ground because it's kind of forcing you to think away from technology and more about the business architecture. And because of that, you're sort of forcing the social architecture to work, because if you want good feedback from the business, you're going to have to treat them respectfully, with kindness, and trust them. And that's really what this is all about.
Thank you very much. Unfortunately, we are running out of time and we don't have time for more questions. But if you have any questions, please leave them in the chat, and our Vaughn will be able to get back to you with the answers, and you will be able to find them on the talk page, on the community page. So firstly, I would like to thank you, Vaughn, for the insightful presentation. I really enjoyed and I learned a lot. And I think the same our audience. Thank you very much for being with us today and sharing your knowledge and expertise.
Thank you so much, Marta, and the rest of the organizers. It was a real pleasure, and you're such kind people to work with. I hope we can work together again.
Oh, that would be great. I would love that. So thank you everyone for joining. Unfortunately, it's our last speech during the EngX Community Days, but stay with us for the conference closing. Thank you.